Okay, so you have to pause this video to get the last of these properties down, the ones that I didn't get a chance to get to in class. Okay, so go ahead and take a second and get these down right here. Just to give you a heads up, all right, these are B's at the top, these are A's at the bottom, these are K's, okay, and it's A and B across the top of all of these integrals, okay? All right, this is a B at the top and A down here. This is an A, this is a B, okay? So go ahead, pause this video, and write these down. All right, so hopefully you're writing these down, okay? And if you notice, the first one is basically like the constant one for the definitive integral, except this time you just have a lower and upper bound, okay? So you still pull out the constant, and then you take the integral of the function, and then evaluate from A to B. Just multiply on the outside. Here, the second one looks just like the sum one, okay? And this can go both ways, so go ahead and put a plus or minus underneath there. Okay, so you just basically do the antiderivative of the f function from A to B, and then the g function from A to B, and then add them together or subtract them. This one is different. As you see, going from the lower bound A to B of one function is the same thing as going from B to A, but it's negative. Okay, so you would integrate, and then you just make it negative. Or we went over in class. Okay, or if you watch the other video, is what we went over on the other slide. And then the last one, if you're evaluating with the same bound, then of course the integral is 0. So you need these few properties to try some problems like the ones that are on this page. And I forgot to write them down, so I'm going to write these up real quick. Okay, so for the first one, or for these functions, it's asking you, given that the integral of f of x is 4. Oh, and I forgot my bounds. I just noticed that. Okay, so this has a bound from 0 to 2. This has a bound from 2 to 5. This one has a bound from 0 to 2. And this one has a bound from 0 to 4. Okay, so there are your bounds. You have all these different bounds with these different functions. You see the first two are with f of x, the second two are with g of x, and they actually equal a number, okay? We haven't gotten specifically to using the definitive integral to find the area underneath the curve just yet. That's for Monday. I'm just trying to get you guys to be good with the properties. So if you look, we have the integral from 0 to 2 of 3 times f of x minus g of x dx. Well, there's a minus here, so remember we can use that one property that basically separates the two functions, okay? So this is what you're going to have here. Using that one property, I believe it was the second one, using the second property to separate it like so. If you look in the very first part, the one that has the 3f of x, you can actually apply the constant property, the very first one, and pull out a 3 to get this. All right? And what you notice is that if we have the integral from 0 to 2 of f of x dx, that equals 4. That was right up here in our directions. So I can replace this entire part right here with a positive 4. So this becomes 3 times 4 minus the integral from 0 to 2 of g of x dx. That's the same thing as saying negative 3. So I'm going to replace that with a negative 3. 2 negatives make a positive, so this becomes 12 plus 3, which equals 15. So the integral from 0 to 2 of 3f of x minus g of x dx is 15. And then that's how you use the properties, okay? The next one, okay? The integral from 2 to 2 of g of x dx. Remember, this is the last property on the previous slide that says anything with the same bound is going to be 0. So I'm going to replace that first part with a 0. Okay? And this last part almost looks like the integral from 2 to 5 of f of x equals 12. The only difference is that the 2 and the 5 are switched. Okay, the third property told us that I can actually make this a negative and flip the integral. Okay, so this becomes a negative 12 because I can replace this entire part right here with a 12. So my answer for B is negative 12. Okay, let's keep looking. All right, let's look at this next one, okay? So C, the integral goes from 0 to 5 of f of x dx. The only thing is if you look at all the things that were given to us in our directions, we don't have one that goes from 0 to 5 for f of x. But we do have one that goes from 0 to 2 of f of x, and then one that goes from 2 to 5 of f of x. So you can think exactly what we're going to do. We're going to add those together. And then that will give us the integral from 0 to 5 of f of x. So that's going to be 4 plus 12, which is 16. So the integral of 0 to 5 is equal to 16. And now the last one, okay? We got a constant out front. We have a constant out front. So we can move that outside of the integral. And if you notice, I have a plus 3 on the inside with the x. I don't have that in any of the parts that were given to me. But what I can do is I can basically add the 3 to both of my bounds. Can I do that? Yes, you can. Just like if this was a minus 2, if this was a minus 2 instead, you would subtract 2 from each of the bounds. And look what happens when you do that. I'm going to add 3 to both of my bounds. So then this becomes 1/2 0 to 2 of f of x dx. And so now I actually have an integral, a definitive integral of a function that was actually given to me. So this becomes 1/2 times 4, which equals 2. This is the last part that I didn't get a chance to cover in class. And of course, it's the second half of the video for those who were absent. So if you have any questions, please let me know. Just remember that your take-home quiz is due on Monday, and you're doing that without a calculator and without the help of other people, okay?